Hey pre-calc students, how we doing? Hopefully things are going well at your home and you're spending time with family and getting things done. I wanted to talk before we begin. I want to just note I'm looking at the views and on the YouTube on the videos, and on one I have like a lot, and then the next one I have 10 views. Okay, so I have 11 students and 10 views. So either, and it doesn't count if somebody watches it twice or something. So that'd be a problem. So, and that was 2 sections ago. So that's telling me someone's just not watching or not doing the work. So I'm not going to call out names or anything, but this is on you guys. I'm trying to keep it minimum, but this is on you. And then the most recent one was only 3 views. So that tells me that there's a lot going on. And I know the juniors, you guys have a lot going on. Another question somebody asked me is, why am I not wearing my glasses? Well, for close, I don't need them. It's when I'm looking farther, and that's what gives me a headache. And then the lights in the building sometimes give me the migraine. So as long as I'm not looking distance, I don't usually need them. But all right. So we're going to dive in. This is should be an easy section. I'm going to give a break. Okay, you're going to give him cues for coursework, and they kind of tie into each other, and then this. So the berating you, so to speak, is over. It's on you guys, so get her done. Test is upcoming April 17th. So we'll finish 9-7 on Monday, Tuesday. So this should be an easy section. You should get caught up. Okay. 9-8's the hardest one. It's putting it all together where we're, trying to, maybe we have an ellipse or something that's terrible, and then maybe we have a hyperbola here, and it intersects at 4 locations. All right, and we want to find those solutions. We want to graph it, and we want to find the 4 solutions where these 2 graphs intersect. Or maybe I have a line like this, okay, and maybe it intersects only at 1 location, and then where oops, right there would not work. So, anyways, you get the idea that if I had a line or third, maybe I had a circle in here. Yeah, let's draw a circle. Kind of, there we go. Okay, and so maybe intersected here and here. So this is called systems of quadratics, and so we're interested in that. That's coming up next, but this is today. So for most of ours, we have not had an XY term. Okay, and so that's been nice. Algebraically, how do you separate the two? You can't. You can't separate the two to get in the format that we have. We have a trick that allows us to determine what it might be. Okay, but it's not 100%. So we have the best way is to pointwise plot, meaning grab an x value and then crank out the y value. Grab a y value and crank out the x. So if x were 0, then we could crank out the y value, and conversely. So so by making an XY table, that's probably the best way to figure out what this shape is. I'm going to tell you right out of the gates, this one is an ellipse, okay? But the only way I would know this is by pointwise plotting, okay? But I can narrow it down to whether it's a circle or an ellipse. So on your book, on page 496, you've got this. Okay, this is it right here. This tells us, you can see, if the discriminant is less than 0, it's a circle or an ellipse. If the discriminant is equal to 0, it's a parabola, and if the discriminant is greater than 0, then this is a hyperbola. Okay, so then that begs the question, what is a discriminant? Let me fix that. Okay. Let me pause and get it fixed. Okay, so in a quadratic function, normal, just a parabola that we did last year in Algebra 2, you have y equals ax squared plus bx plus c, and the discriminant in a quadratic function is what's underneath the radical, the b squared minus 4ac. So if this is negative, we know that's a complex solution, all right? There would be an imaginary number underneath here. If it's 0, then we know that the vertex would be touching the x-axis. If it's a perfect square, that's nice. That's going to come out as a nice, good happy clean integers for our x-intercepts. Okay, so what is the discriminant for quadratic relations? Okay, so on the same page, we've got this. This is their quadratic relation equation. Very beginning of the chapter, this was listed. Okay, so I'm going to take our equation up here and just line it up. Okay, so we can see that this would be 1. Okay, this would be 1. This would be 1. There'd be 0x. There'd be 0y. Again, I'm looking at this one. And then just subtract this. You don't have to subtract 90 to this side. It's irrelevant because it's not part of equation. So what do we do next? Okay. Okay, so this is our discriminant from this equation. It's just b squared minus 4ac. But it's different than this one because the ABCs are in different locations. So b squared, which is 1 squared, minus 4 times a times c. So it's 1, whoops, not 4, that's negative 3. Hello, I can do math. Okay, so 1 squared minus 4, and then we've got negative 3. Okay, and so on your book, again, this here, right there, says a circle or ellipse. The discriminant is less than 0, it's going to be a circle or ellipse. If the discriminant equals 0, then it's going to be a parabola. If the discriminant is greater than 0, it's going to be a hyperbola. Okay, so that's all you have to do is just line it up, find the discriminant, and then tell me. So here, all I could say, my answer would be this. So earlier I said it's an ellipse, but all I can determine is whether it's a circle or an ellipse. All right, so that's the best we can do. Then I would have to do a point-wise plot and then get that. But for you, for me, all I want you to do is determine this. So determine what shape it is, and if the discriminant is negative, then at best all we can do from this information is narrow it down to a circle or an ellipse. Okay, if there is no xy term, okay, we can follow the rules that we had earlier. If you remember those, you know, if we had x squared plus y squared equals 4, we can know that's immediately a circle. Okay, because all we have to do is focus on the squared terms and see that the signs and coefficients are the same. Okay, if I had something like this, okay, all right, we can see that this would be a hyperbola. Okay, and I'm ignoring the x and the y term. All right, there could be an x and y term, but if there is an x multiplied by xy term, okay, we haven't done any that we solved like this, then at most we can just determine its shape, and then we have to point-wise plot them with an xy term. So if you've noticed, they've all not been there. Okay, I'm going to sign off. May the Lord bless and keep you. All right.